Looking at this devastating photograph of a child severely wounded by the August 6th, 1945 atomic bombing of Hiroshima by the United States set me thinking about how one can never tell what consequences an idea or a thought may unleash, let alone where, when, and how. In 1905, Albert Einstein published a paper titled Does the Inertia of a Body Depend Upon Its Energy Content? In Annalen der Physik. The ideas in the paper were the precursor to history's most famous equation, E equals mc squared. Simply put, it means that energy in a system, it could be an atom, a person, or anything else in the universe, is equal to its mass multiplied by the square of the speed of light. It was this equation that would eventually lead to the creation of the atomic bomb, helmed by the physicist J. Robert Oppenheimer as part of the Manhattan Project. Think about the tangential nature of life, in this case, that of the Japanese child who was at the first municipal elementary school in Dambara, Yamasaki-cho. The child was probably 4 or 5 years old when the first atomic bomb was dropped on Hiroshima. That means the baby was born around 1940, 35 years after Einstein theorized E equals mc squared. Between E equals mc squared and Hiroshima and Nagasaki, so much else happened, including the grotesque World War II. Let me just offer a bit about Oppenheimer, as well as about German physicist Lisa Meitner and chemist Otto Hahn, who discovered nuclear fission. This is what the Einstein Prize winning physicist and a pioneer of quantum loop gravity, Dr. Abhay Ashtekar, had told me as part of a special interview 3 years ago. It still retains its relevance. Let me begin with a broad question. The, the popular perspective is that a somewhat uncertain Oppenheimer on the verge of unleashing unprecedented power and energy found strength in Kalos me loka kshaya kriti pravardo. Now I am become death, the destroyer of worlds. What's your perspective of that?
Okay. So you want a short answer, or can I start from scratch?
You can start from wherever you want.
Okay. So, I mean, I think I should start with Oppenheimer himself, right? I mean, he was a very, very unusual person. Even even for a great scientist, he was a very unusual person. Uh, he was born in a quite a wealthy family in New York, and he was a prodigy. So already at the age 13, he had done on his own some research on the rocks in New York and around New York, and submitted a paper. And the New York chapter of the Geological Society invited this speaker, and his father encouraged him, and father took him, and they were completely shocked to see this 13-year-old boy. And so they had to they led him to the podium, and he could not reach the mic, so they actually had to put a stool on which he had to stand and give a mic. And he gave a good talk, and they all appreciated it. I'm giving this anecdote early on to just sort of say how he was really prodigious. Then he did his PhD in Cambridge, and when he was a graduate student, he really had developed a great dislike to his tutor
I say.
because of some experimental work and so on. And there are some accounts which say that he actually tried to poison the tutor, and then he was caught. But again, being so suave and so intelligent and so perceptive, he somehow managed to, convince the main people, right? I mean,
Yeah.
the master of the college and other people,
Okay.
and that that. So he was only given some small reprimand, and he was not, not much was done. And then, of course, he was a professor in Berkeley and so on. And actually, before this Manhattan Project even became official, he had done work in nuclear physics and so on. But then he got interested in general relativity. And actually, I think in September of 1913, September 1st, I think of 1939, he had his paper appeared in Physical Review uh, at that time, and it was about the so-called Oppenheimer-Schneider collapse. So this was kind of a definitive proof that stars when they run out of the nuclear fuel, would actually form a black hole. And as Freeman Dyson, for example, says that this was the earth-shaking paper, and but the reason is it was not so well known was that was the day on which Hitler invaded
All
Poland,
right.
exactly that day.
Amazing.
And so that paper was not didn't receive much attention much until much later. I mean, and like Freeman Dyson really analyzes and feels that this was the deepest work, that scientific work that Oppenheimer had done, and it has ramifications even now, right? Okay, then let's turn the story to the atom bomb. And so in the atom bomb story, one, I mean, as you probably know, in the Christmas of 1938, Lisa Meitner and Otto Hahn realized that what they had seen in the lab was actually a fission. That is to say, a nuclear reaction which could go on to chain reaction because it is triggered by neutrons. And the statement was that at any time the neutron hits the nucleus, it converts, changes the nucleus, but also it emits more neutrons.
Right.
And therefore it can hit more nuclei, and therefore the chain reaction can
Right.
start. So they understood the potential of it, but they were apparently, as far as I know, Fermi actually had similar experiment 4 years ago, but he did not realize that this was nuclear potential
Fission, yeah.
chain reaction. And so anyway, Lisa Meitner and Otto Hahn, they both realized the potential, and they, I mean, at least Lisa Meitner has had some ancestry which was not compatible with the Nazi
Right.
regime, and so she did escape. And the news then was channeled outside Germany that this was happening in a very secret way. It was channeled up here. By the way, on the same issue of physical review, September 1st, there was another groundbreaking paper, and that was a Bohr and Wheeler on
Right.
nuclear reaction. It was couched in some terms which was not to draw much attention, but it was clear from that paper that that in fact the chain reaction is a real possibility. And so around the same time, 1939, right, September of 1939. So a few months, I mean, 8-9 months after the Lisa Meitner discovery and so on. So, I mean, among the Western scientists, there was a clear recognition that if Hitler had started this nuclear weapon project, then there's no chance that Allies could ever win. So that was really the driving force among the Allied.
Right.
And at that time, people were convinced that Heisenberg was the only person that they were afraid of, actually, the Western scientists, that if he were leading the project, then everything would be gone.
Exactly. Yeah.
Right. And there's just one sentence that made Heisenberg a great, very controversial figure for years and years and years. But the later papers and even people like Hans Bethe, who are in the beginning were thought that Heisenberg was involved, sort of basically cleared Heisenberg, saying that he, in fact, did not encourage research in nuclear weapons, only for nuclear pies, that is to say, nuclear energy. Okay.
Right.
So then the main point was, how do we get this to the attention of the United States government? And then the scientists realized that there was no way for them to talk to FDR or to convey. And if we did not talk to FDR, they just talked to somebody else, people just wouldn't appreciate the potential and the danger that the world was in. And so they had to really get to FDR. And so finally, Leo Szilard was Hungarian, I think. He actually met with Albert Einstein and convinced Einstein of the danger. And then Einstein wrote this famous letter, and that was in August of 1939. And that is when the informal arrangements, the informal first orders from FDR came. They're all secret. But it took still 3 years until 1942 for there to be official chain of command, and that was under General Robert Groves. And so this was really set up. And then a year later, so it was we already talked about 1943 now. So 4 years after the nuclear weapons, the chain reaction had been discovered. that the formally scientific negotiations and scientific structure started happening. And again, I mean, Oppenheimer was not the most celebrated scientist at that time. I mean, there are people like Enrico Fermi, you know, Wheeler, there were many people, Hans Bethe, who had much more experience in nuclear physics and were more distinguished. But it was clear that Oppenheimer had both had very sharp intellect, a deep knowledge, very quick learning things, and had intellectual breadth that he could absorb not only fundamental physics, but also the engineering thing that was needed, which was extremely high level engineering. And so
Right.
you could absorb these things. And also he had a managerial skills. So he, again, as I said, the same skills which got him out of trouble in Cambridge, where at work, when he persuaded Groves that he was the right person for the job, and he was appointed the director of this laboratory.
Coming back to the Hiroshima child, now view the child's destiny over 13,000 kilometers away from Germany, where Einstein first thought of E equals mc squared, against the backdrop of what Dr. Ashtekar talked about. Life's tangents are utterly mystifying. August 6th and 9th mark the 80th anniversary of the Hiroshima and Nagasaki atomic bombings by the United States.